edit it. All right, guys. So today we are talking about gravity. Okay. Can somebody tell me what comes to their mind when they think of the word gravity?
The force pulling
The
us
force
down,
up.
keeping us on Earth.
The force that's keeping us on Earth. Go ahead, Cameron.
The forces are heavy.
The force is heavy. Yes, it is. Okay. Anybody else want to share? Okay. So yes, gravity is the force that keeps us on our feet. Is Earth the only place that has gravity?
No.
Where else do we have gravity?
All planets.
On other planets, right? So Mars has gravity. Pluto has gravity. Well, that's another debate whether it's a planet or not. But Jupiter has gravity. They all have different gravities, right? The only gravity that we're concerned with is Earth's gravity because that's really the only place that we are, right? Okay. So gravity on Earth is 9.8 meters per second squared. Okay. Just looking at that number, let's look at the units. What type of number is that? Say that louder. Acceleration. That is so true. So gravity on Earth is, you'll hear it stated as acceleration due to gravity. Okay? So it's the thing that keeps penguins on the South Pole from falling off of the Earth, right? Because when we look at it, if I draw the Earth right here, gravity is what's pulling everything to the center. Okay? Any questions so far?
No.
Okay. And towards the Earth, gravity is pulling at 9.8 meters per second squared. Okay? All right. Gravitational force, as we're talking about forces, is the push and pull between two objects that have a mass. Okay? So, for example, the Earth is here, and the sun is a long ways away, right? Let's say the sun's over here. Right? But we orbit around the sun, right?
Mm-hmm.
So there's some type of gravitational force that's pulling the Earth towards the sun so it doesn't just fall away, right? Okay. So has anybody ever been on a trampoline?
Yeah.
Cameron, you've been on a trampoline?
Yes.
Raise your hand if you've ever been on a trampoline. Okay. Have you ever been on the trampoline with someone else?
Thomas.
With someone that was bigger than you? Or maybe you were the bigger person? Right? Okay. What happened? Somebody tell me about what happened when you guys were jumping at the same time. Fred, share with us. Yeah. What if, have you ever tried when someone was jumping and the other person just sat down?
Yeah.
Okay. What happens when the larger person is standing there and you sit a little bit too close to them?
You get close to them.
You fall closer to them, right? You fall like to their feet, right? So that person had a mass and you had a mass, right? Your distance is one of the things that determines how strong the gravitational force is. So if you're on the trampoline and the heavy person is standing there and you're standing a little bit too close or sitting a little bit too close and you slide in, that's that gravitational force pulling you towards them. What about if you were far away from them on the trampoline? Would you still slide? No, because your distance is greater, right? So the gravitational force has to do with how much distance you have and how much mass you have. The closer the distance, the more gravitational force you will have. The greater the mass, the more gravitational force you will have. Okay? Any questions on this so far? Okay. Does anybody have the formula sheet? Cameron, you have the formula sheet in front of you?
Yes.
Does it say anything about acceleration due to gravity. Do you see that on there? I think it's somewhere in the bottom.
Yeah, I see it.
Okay?
10.
10. And that's because they round up. So typically, if you were to look online or anything like that, they're going to tell you 9.8, right? But you can assume that it's also approximate. That's what this sign means. Approximately 10 meters per second squared. Okay, so let's move on. So let's talk about free fall. What happens if I drop this marker?
It's gonna fall.
Why will it fall?
Because of
Gravity.
gravity.
Because of gravity.
Because of gravity. Great.
Gravity.
Okay. What if I? No, don't demonstrate on your Chromebook. Phrase. If I drop this marker on Nathaniel's head from this height, is it gonna hurt more than this height?
The highest will hurt the most.
Why?
More speed.
Because you're building up more speed. Remember that the acceleration due to gravity is an acceleration. So what's happening as something free falls? It's accelerating, right? Okay, so that means that if I have something that's falling and I time it, so I'm sitting on the top of Clarkston, the top on the roof, and I drop an egg. The egg is not going to survive. Okay, so this is 0. This is at 0 seconds. If I time it every single second, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and so on and so forth. At 1 second, what is going to be my speed? 10 meters per second, right? Then I'm accelerating another 9.8 meters per second squared. So my next speed is going to be 20 meters per second. And then what's the next one? 30, yes. And the next one? 40 meters per second and 50 meters per second. Okay? So that's how the speed increases during free fall. Okay? Does anybody have questions about this? So anytime a question is asking you about free fall, you want to remember that acceleration due to gravity is at 9.8 or 10 meters per second squared. And that's going to help you think about the speed of that object as it's falling. Okay? All right, let's talk about mass versus weight. Okay? Everybody has used the term weight before? Like, oh, I'm trying to lose weight, right? Or I'm trying to gain weight, gain muscle. You know what I mean? Okay. So, what is the difference between mass and weight? Cadence? Mass is how much space you take up. That is correct. Weight is how much space you take up and how much gravity is pulling on that mass. Does that make sense?
Yes.
Okay, so if I go to Mars tomorrow, I'm still going to have the same mass, but my weight will change because the gravity on Mars is much different than it is on Earth, right? That's what allows me to jump from here to where Henry is standing on Mars, right? Okay, so the way that you calculate the force of gravity or your force of your weight is force W, that means force of your weight times the mass, equals the mass times the acceleration due to gravity. Okay, so what is someone's mass? Does anybody want to share? Somebody shout out, or even if it's not yours, give me a mass.
120.
Oh, realistic mass. 120. Okay. 120. And what is that in? What are my units?
Pound.
Pounds. Huh?
Kilograms?
Pound.
You said pounds. When we're gonna calculate the force, we want to make sure we use kilograms. Yes. So let's say this was grams. We're gonna convert it to kilograms. Okay. For the sake of our example today, we're gonna do 120 kilograms. And then what's the acceleration due to gravity again? 10. 10 what?
Meters per second squared.
Yes. So remember, we always want to keep our units. Okay, so someone did 120 times 10.
1,200.
200.
1,200
200.
Meters per second.
meters. Well, really,
Kilogram.
what would our units be for force?
Newton.
Newtons. Yes, our units for force are newtons. So that would be the force of our weight. Okay? Questions so far? Okay. Has anybody ever, what do you think of when you hear the word work? Doing things. Makai, what do you think of when you hear work? What do you think of? Getting money, yes, a job. Anybody else? What do you think of when you hear work? Jobs, money, okay, doing things. Okay, so work is the transfer of energy when a force causes an object to move over a distance in the same direction of the force. Okay, so let me ask you a question. If I move this, I'm pushing on it and I move this, am I doing work?
Yeah.
Yeah.
What if I pull it this way? Am I doing work?
Yes.
Okay, that is because I'm doing a push or a pull, and the object is moving in the same direction of that push or pull, right? Formula. Work is equal to force times distance. What's the definition of force again? What's the definition of a force?
What is a force?
What is a force? I just said it. A push or a pull. Push or a pull. And do we know what the meaning of distance is?
How far?
How far? Okay. So, if I don't have any distance, when I was pushing the desk did not move, right? So my distance was what?
0.
0. Does it matter how much force I do?
No.
Anything times 0 is
0.
0. So that means my work is going to be
0.
0. Exactly. Okay, so you have to have both force and distance to have work. What is the units for work? Joules. You said it right too. Awesome. So like a joule, like jewels in your ear and your bracelets, but it's spelled like this. Okay? All right. What about power? What do you think of when you hear the word power? Just shout it out. What do you think of when you hear the word power? Lights, energy. I think of the TV show. Force. Okay. Say it again. Star Wars. Yes. Use the force within you. Power is how fast you do work. So, if you're thinking about climbing the stairs, you're trying to get to class. If you're climbing the stairs and you climb the stairs faster, you climb the stairs in 10 seconds, and then you climb the stairs again, and this time you climb the stairs in 30 seconds. Which time was I doing more work? I mean, more power.
10 seconds.
In the 10 seconds when I did it faster, right? Okay, so that's what power is. It's the work done divided by the time that it took you to do that work. Okay? So let me ask you this. If I had no distance, If my distance is 0, will I have any power?
No.
Hmm? No. Why? Yes. For work, you need distance. And for power, you need work. Exactly. Okay, so let's look at the triangle for this. Okay. What if they give me work and they give me power? And they want me to find time. How will I do that?
Power times work.
Work over power. So remember, this is divided right here. This is divided. If it's next to each other, you're going to multiply. Okay. Questions? That was a lot of information. It's really, really important that you guys go back and look at these videos. There's a video for each section. Okay? And it says, how much work is it to lift a 20-kilogram sack of potatoes vertically 6.5 meters? Okay, the first thing I like to do when I'm answering a question is write down what I have, right? So what do they tell me? They tell me I have a sack of potatoes, right? Okay, and how heavy is my sack of potatoes? 20 kilograms. Okay, and how far am I going to lift it?
6.5 meters.
Okay, and what are they asking me to find? How much work? So what is our work equal to? You can, if somebody has Verge pulled up, you can pull this page up. Distance, and what else? What else do I need to have work? Force. Force times distance. Okay? Alright, so do I have a distance? Let's look at our units. Do I have a distance here that they give us?
Yes.
What is it?
6.5.
6.5 is my distance. Good. Do they give me a force? Because they have to give me force and distance in order for me to find work, right?
Yeah.
Okay, so we don't have a force. How am I going to find the force?
Divide work and distance.
Okay, we could do that, but we would need a work. That's what we're actually looking for. Okay, so we're going to use this equation right here. Remember when we multiplied our mass times our gravity to get the force
Yeah.
of that mass?
Yes.
Do we know what gravity is?
Yes.
Okay, what is it?
10.
10 meters per second squared. And what is our mass?
20
20
kilograms.
20 kilograms. Okay, so what is 20 times 10?
200.
200. And what are my units? What are my units?
Newton.
Newtons. Okay, so now can I use this for my force?
Yes.
Okay, good. So now 200 times 6.5. Somebody do it for me.
It's a big number.
1,200 and
Fred,
1,300.
13,000.
do 200 times
1,300,
6.5. You already got your phone in your hand.
1,300.
1,300?
13. Yeah.
1,300? Is that what you got?
1,300.
Okay, we're gonna say 1,300. But am I done yet? This is my answer?
No.
No, what am I missing?
Joule.
Joules. Okay?
Still need that.
Okay, questions on this?
Alright, this was a lot, y'all.
It was a lot of information, and I went through it really fast. Henry, thank you for videotaping.
Now we got a whole lab.
Don't forget to